Welcome everyone, I'm super excited because this is a lesson that I've been waiting for months, since January. Today we'll talk about the match statement, the match construct in Rust. The match statement compares values against a series of patterns and then it executes code based on the matched pattern. This very simple definition, it's something that I've been looking for since I started programming. Like, I want to have multiple flows based on a condition. Here you can see an example. Of course, we'll do a live demo, no worries. We are using an enum here. I want to show you the anatomy of a match expression. This is very important to understand. It's a bit complicated. Not complicated, but it's a bit hard to understand. You see here we have a function main. We define a number equal to 7, and then we use a match expression. We have the match keyword, a value that has to be matched. In this case, it's number, but it's not a type, it's just the name of the variable. On the left, we have these patterns. For specific values, we have 1, 2, 3, and underscore. We will see at the end of the lesson what this underscore stands for. And then we execute some code. You see here on the right, we have actions to execute. We have this fat arrow, I love it, which separates patterns from code to execute. And in this case, we do something very simple. We print the number in letters. Let's compare the match statement with the if, the famous if. The if is very simple. It's simple for basic conditional branching to decide this or that. And it can do simple checks. It's a boolean, the condition, it has to be a boolean, true or false. It can handle individual flows for each single condition. If we have more than one condition, the if starts to become a little bit hard to use. And it's not exhaustive. I don't know if you ever tried to use an if-else structure, for example, to handle HTTP errors. Also, there is no pattern matching and binding values. They are simple flows that we can either do or not. Let's see the match statement. It's more sophisticated, so it's a bit more complicated, but it has this advanced pattern matching. So we can match different things and then execute some code. This is my favorite thing about the match statement. We'll see an example later. A match statement ensures all cases to be handled. It will force us, developers, to implement all the cases. It's also very concise, it supports value binding, and it allows to return values. The match statement can be evaluated to a variable. We don't have the switch statement in Rust. You might think that the match is just a switch. The Rust Foundation just decided to call the switch match. No. The match in Rust is not a switch. It's a switch on steroids. And now I'll show you 4 reasons why the match is different from a switch statement. To see these differences, we'll use the switch in the C++ language. Match versus switch. One difference is the pattern matching. Match enables a more complex, also flexible way of matching on different types: enums, structs, and tuples. Let's see the example here on the left. We have this switch in C++. When we use a switch in C++, we can't use a string. So this might be a problem. Let's say that we want to have different cases based on the name of the fruit. I want to give different colors based on the name of the fruit. So in this case, I need to add a workaround. For example, I can create a struct with an int ID, for example, 1, 2, and then I can have this switch statement. It works, but I don't want to think every time, can I use the switch with this? Can I use the switch with that? Check the match statement on the right. It has the struct with a name and color. And check how short the code here is. We have a function with a match on the fruit name, apple, red, banana, fat arrow, yellow. This is my favorite one. Match versus switch. Exhaustiveness and uniqueness. Rust, match, and forces. Handling of all cases, avoiding these bugs. On the left we have an enum and then we have a switch again in C++. We can use a switch for enums in C++, but check this out. We have this switch with apple and banana, but in the enum we have apple, banana, and orange. And maybe we forgot to give the implementation for the orange. At some point in the main function, we create an instance of an orange and we want to get the color. And only here we will find out that this is a mistake, that this is a problem. The switch didn't throw an error, we just didn't implement one. But check here on the right, we have this match statement. In this case, we implemented all three the fruit color. We have apple, banana, and orange, and then we create an instance of apple. But what if we forget to implement this one, the first line? In this case, something magic will happen, the dream. If I forget to implement some values of the enum, if I use the enum in the match statement, guess what? The compiler will throw an error. And this is good. This is amazing. This is probably exactly what we want, because we want this to be implemented. Of course, there are workarounds. I can decide, for example, to do nothing in this case. This is a way to try to save developers. Third difference between match and switch. Binding values. It allows binding values to variables within the match arms. The arms are basically the lines of the match statement, and this makes it way more flexible. Check here on the left, we have this enum, and then we have some cases. In this case, you see, we need to use this variable inside the case statement here, and then return it here. And in input, we have a single value for this function. It works. But check how the match statement allows us to implement the same concept. First of all, we have this enum with types. And here we have, check here, we have this match fruit, and then we have this weight here for this arm, and then we use it. And then we can have the length here, you see, it's in the pattern matching here. And then you can use it inside this piece of code that we want to execute. If we have only one line, we usually don't use curly brackets, but we'll see an example. If we want to have multiple instructions, we can just open curly brackets. It's very similar to the arrow function in JavaScript. If you're not convinced yet, here is a fourth difference between a match and a switch statement. I love this. Return values. Match can return values. Match can be evaluated. Each arm can have its own return value, and then the entire match evaluates the value of the matched arm. Check the switch on the left. This is what we have been used to do with switch statements. We declare a variable here, double price, then we create this switch statement. We have different cases. Then, for each case, we assign a different value to this price, and then we use a break statement. Check this out. Let price equal match. The match evaluates to something. We can have let price equal match, fruit, and then apple, arrow, number, banana, arrow, number. Else, this is basically the default, arrow, 0. That's it. I was trying to implement the match the first time like if it was a switch. So I was trying to, define a variable inside the match, and it was not possible because inside the match you only have the arms. In a match, things are evaluated line by line. So it will check the first one. If it's not working, it will check the second one. Otherwise, it will check the last one. Let's see a demo. Let's create an enum called coin, and we can define different types of coins. For example, penny, nickel, dime, and quarter. We can use a match statement to do something with these types. Fn value in cents. We have this function with this coin in input, and in output it has an unsigned integer, and then we have a match coin with the value in cents of each coin. And now we can create a function main here below that defines a coin, for example penny, and then it prints out the value of the coin is. Cargo run. And we can read here the value of the coin is 1. We can avoid these warnings like this. Allow dead code. Don't do this at home, but now it works. Okay, now you can read the value of the coin is 1. This is of course just for demo purposes. We evaluate this coin trying to match all the arms. Coin penny, coin nickel, coin dime, coin quarter. In this case, we stopped on the first one. So coin penny 1, and basically we return 1. Let's say that for the penny, we don't want just to print a 1, but we also want to do something else. For example, we want to print an additional line. Print ln, for example, like this. And then we return the value. If we try again this one, now we can do some extra things. For example, we do this only for the penny. If we create something else, for example, the nickel, and we print out also the value of the nickel, for the penny we also print this extra line. We are basically here. For the nickel, we just return 5, and this is absolutely fine. I love how we are free to do whatever we want. I told you that we can bind values in the pattern matching, in the match statement in Rust. Let's try to define, for example, a rarity of coin. We can do an enum, of course. We can call it rarity. And we can have a common, uncommon, rare, epic, and legendary. It's okay, it's just an example. I want to copy also this line here. For the quarter, only for the quarter, I want to add a rarity. Let's say that I'm collecting quarters. It's probably a thing. It was probably a thing. This is very powerful because here we can have the rarity only for the quarter and not for the other types. Here we can have something like this, check line 27, quarter with a rarity, and then we print n the quarter rarity, and then we return the value. And let's say that I want to get something like this. Let coin quarter with a rarity epic, and then we print the value in cents of this coin. Let's try. We need to add this derive debug on line 11. Let's try again. And now it works. And you see here we can print some value. This is very flexible. It shows how flexible the match statement is, because you have a quarter with a rarity with this type, and we can create an instance with this rarity, but we don't need that on all the enum types. And now I want to try to use match with option T. Option is a very special enum that is basically used to handle null values in Rust. In Rust, we don't have the null. I want to show you here how it looks. Enum option. Okay, so this is just an example. I don't want to override the official option, so this is one example, but I want to comment it. Okay? It's just to have an idea on how this enum looks like. And by the way, this is embedded in the Rust code. We don't need to add option double colon. We can just use sum and none inside the language. We'll try to use the match statement to actually do something and try to sum some values in a proper way. Here we can create this function. We can call it +1, and this is okay. So this function has in input an x, which is an option i32. Option i32, it means that it can be a sum i32 or a known value, and it will return an option. And here we have a match statement. This is why we are doing this today. If we have known, we execute this part known. If we have some value, we will see this with an example in a few seconds, then we'll return sum I plus 1. And now let's try this out. This can be embedded in a main function. So fn main like this. And now we can define this variable called 5, which is sum 5 in parentheses, and then we can have this variable called 6, which is plus 1, 5. Let's say that I'm adding two numbers in a super secure way. And then we can print this value, cargo_q, and we have this sum 6. We defined this variable called 5, sum 5, and then we called this function plus 1 with this 5 parameter. We went inside this function plus 1, then the match statement tried to match this sum 5 with something here. So it started with known, no, it went on the sum I, and then it executed this sum I plus 1, which is 6. And then it returned this, and this went inside this SIX variable. So in the 6 variable we had sum 6. This is the flow of this match statement in this case. If I try to add this known to something, let known plus 1 known, and we try to print it, in this case I get none. Since I pass known as a variable for this function, it goes inside this arm, line 10, and it just returns known. I told you that the match statements are exhaustive. It means that if by mistake I remove this from the match statement here, and I remove this here, I get an error. Not known exhaustive patterns. Known not covered. I love this. It's forcing me to do, at least do something. Check here. Known to do something. At least you have to put here known. And then if you want, you can also do nothing. We will see this with an upcoming example. This is basically saving me from doing dumb mistakes. I want to show you this catch all pattern. I want to try this example. Let's say that we have this one. Let dice roll equal to 9, and then we can have match dice roll, and we can have different examples. Let's say that we have this pattern matching 1, 2, 3, 4, 5, 6, and then we print a statement. This is basically just to simulate to the execution of a piece of code. Otherwise, we do something here. Okay, let's wrap this piece of code in a main function. Okay, you rolled something else, but you see that we have this warning. Here, the match statement tried all the possibilities. So we have 9, it tried 1, 2, 3, 4, 5, 6, and then other. The problem is that since here we had this pattern matching at the end, it printed this part, which is the last one, the catch-all pattern. Of course, it always had to go at the end. Maybe here we don't want to use this other variable. Can we just say, okay, I just want to do something. In this case, I can use an underscore here. Let's try again. And now we don't have the warning anymore. What if I want to do nothing? Let's say that in this case, I don't want to print a statement. I want to basically do nothing. I want to fail silently. I can just put like this. Let's try like this. No output. Let's say that on 4 we do nothing. First, let's try with the number 3, cargo_q. You rolled a 3. If instead of 3 I put 4, it does nothing. So if we want to do nothing, we can have these parentheses. And this is the end of these few examples using the match statement. The match statement is very powerful. For example, I've used it to create a web server. To create a web server, you can have a match statement, and then based on the request, you can basically create a router. I think for a simple web server, I will definitely use a match statement based on the server. It can also be super useful to handle different types of errors. For example, let's say that we have an error, but we don't know which kind of error. We can use a match statement, for example, with error codes. It's super useful, and I really like the syntax. It's probably one of my favorite syntaxes ever, let's say, since I started coding. Huge fan of match. You will see me being very bullish about this statement that it's really missing in other programming languages. I would like to know from you, what do you think about this statement and how it can be used? Pie Trader, how come I haven't subscribed to this channel? I don't know. You solved the bug. You solved the issue. Okay, I hope you enjoyed it.